how many of you are developers? Awesome. How many of you use TDD, test-driven development? Okay, a few. So many of us that are TDD practitioners, we normally say that TDD leads to good design. How many of you think that TDD helps with your design? It's got a few hands. Okay, cool. So I've been saying that TDD leads to good design for quite a long time. If you go back to my talks and books and everything else, you'll find me saying this over and over again, TDD leads to good design. I'm sorry, I changed my mind. So I've been thinking about how I work, and also how other developers work, and why some people can use TDD to actually drive good design, and others can't. So why some people just very quickly write test after test, and they're very happy with the result, and others are not. So that made me, also when I'm pairing with people, they always ask me, like, how do you do this? Like, why are you starting at this point? What led you to start with this class? And so that made me think, because I was never able to explain that properly. So thinking about how I work, and a few other developers work, I think that TDD is actually a software development workflow. So I think that you are familiar with this. So we have red, green, refactor. Are you all familiar with this? Yeah? So kind of no-brainer, right? So there's not much to explain here. You specify the behavior that you want. You make it work. You come here and make it better, right? Write a failing test, make it pass, make it better. So the thing is, it doesn't take much to understand this, right? I don't think that any developer would not understand this. So why are we so bad at it? Right? So why we can't just use this simple workflow to drive our design? So a lot of the things will happen in here, right? And although I think that it doesn't lead to good design because there's no prescription. So specify the behavior, make it work, make it better. But what is make it better? There's no prescription that will tell you what to do at all. And then some people will say, are you familiar with the 4 rules of simple design? Some people. Right. The problem is that they are not even enough. So basically they are pass all tests. There are many different ways to write them, right? So reveals intention. Reveals intention. And then we have no duplication. And then fewer elements. So normally, so those rules, they were created ages ago with Kent Beck when he started the extreme programming. And so a lot of people believe that just following the 4 rules, mainly on this refactoring phase, you would get to a better design. What is fair? The problem is, this is not part of TDD. So a lot of people say it leads to good design, but this is a design tool. There's a set of prescription, but as there are many other design tools, and domain-driven design, and solid, and patterns, and design by contract, this is just one of them. So I'm talking about pure TDD and the effects that it has on the design side. So the interesting thing is that what I'm going to do, I'm going to go through different styles of TDD and talk about how they impact on the design. So do you know that there are 2 main styles of TDD? So not all TDD are the same, basically. So you have one thing called the classicist, and then the other one is called outside in. Those are the 2 main styles of TDD. So what I'm going to do is I'm going to go over them, and then explain the differences and their impact, and the pros and cons as well. So the class, let's start with the classicist. This is the original one. That's what came from Kent Beck with extreme programming. The interesting one of these, the interesting thing about the classicist when it comes to design is that you write your tests, you make it pass, and then design. And the classicist approach, no, I have another color. Design happens in here. So that's where normally design comes from in the classicist approach. So the main characteristics of the classicist approach are, oh, by the way, many different developers, although there are two main styles of TDD, different developers use them slightly different. So you may think, yeah, but that's not exactly how I do this. That's fair, but I'll give you the general way of using those two styles. So classicist, the first impact is design happens in here. It's basically like, when it comes in here, say, make it better, whatever that means. So the tests normally are state-based tests. What it means, you write a test, you invoke a method, you get some state out, and then you assert that state. So that's what is a state-based test. And during the refactoring phase, the unit under test gets bigger. So I'll give you an example. So you write, so a few tests, let's put tests. So let's say that you are test driving class A. Then you write one test. So you write one test, create class A, put some behavior. A new test, this class gets a little bit bigger. Another test gets a little bit bigger. And more tests. So basically, as you are growing this class, test by test, you start using, normally in conjunction with this, you identify duplication, abstractions, and stuff, and then these will lead to classes to be extracted. So that's how, through TDD, this type of stuff will emerge. But of course that, understanding this, you need to have some good design skills. Because what TDD is saying to you, make it better. The ability to look at your code and figure out what is in there in terms of abstractions and duplications is totally up to you. Right? So that's why I say it's a workflow. And of course that the unit under test, what started with a single class, as you go test by test, and classes were being extracted, now the unit under test is bigger. So all these tests now are testing the whole block as a whole. So, are you familiar with mocks? Okay, half of you maybe. I'll go through it later on. So, a few other characteristics. There's no mock. You normally test the whole thing. You just use mocks on the boundaries of your system, things that you go to the database and stuff. A great thing about this style is that it kind of prevents over-engineering. Because all the design decisions that you make, they come from the code. So you get feedback first, and then you look at what you have, and then you make it better. So it kind of constrains over-engineering. It's much easier to understand as well, because it's state-based, and it's very good for exploration. So what I mean is, like, when you don't know roughly your domain, or mainly data transformation and algorithms, there's no anchor. Like in data transformation and algorithms, there's no domain language in there. There's nothing that you can anchor your thoughts, like a client or make a payment thing. There's no verbs and nouns. So this is a good style for this sort of stuff. It works for business, but it's also good for exploration. So let's talk about some of the problems with this. So the impact of your design can be even negative, because you are already exposing state. Right? So in order to test this way, you need to expose the state. You may be breaking encapsulation, stuff like that. So refactoring is a constant activity. Every new feature that you add, there's refactoring to be done. Although this is not entirely a bad thing, but when you are doing too much refactoring, something is a bit wrong. You're not being optimizing your work, really. Another thing that this leads to It's very common in the classicist approach, mainly with beginners. Because you write the specification, then you make it pass. It's very often so like, well, it works anyway, seems good enough, and then you are red, green, red, green, red, green, red, green, 2 months of refactoring later on, right? So you forget this step here. So that's one of the problems. There's another thing. So a lot of people say, no, this is great, and it's simple because my test tests a whole unit. It's great when you stop here. Well, let's say that this is feature 1. And let's say that now we introduce feature 2. And feature 2 will have some tests that will test a new class. It will have the same effect. And then you extract maybe another class. But then, once you extract this class, these classes now, they have their own life cycle, right? They have a different rate of change. So the behavior here was important enough to deserve a place in your domain. And that's why you extracted them. But once you extract them, they have a life on their own. So they can be reused. So there are cases where you may have something that, imagine that this is a continuous thing, right? So it may reuse something in here. And you can go for feature 3, do the same thing. So that would be F, and then extract a new class. And then all of a sudden, your unit under test is something like that. Until this guy here changed the constructor, goes to the outside world, because different forces now are making these classes to evolve, goes to a database or something, or just changing the constructor. You have all these tests broken now. Some people say, I don't have this problem. It depends. If your system, if you are working on a complex system, you may end up with this. I'm not saying that you will. But if you are in a CRUD application that each feature is completely independent, like go from the page to the database, that's all the CRUD stuff, and another feature is a different domain doing the same thing, you don't have overlap. But in a richer domain, this may happen. So another thing that the classicist doesn't prescribe direction. So imagine that this box here is your system. You have a few user stories and acceptance criteria and all this kind of good stuff. It doesn't tell you where you start, right? The classicist. You can start from wherever you want. So you may put a class in here and say, I think that I may need this class, and then you start exploring, create a few other classes. And then at some point, you still need to, like this is the input, so this is the trigger to your application, that's an output. At some point, you need to connect these things. You may end up with a tunnel problem. Another thing, because the design always happens in here, we always wait to have concrete evidence in order to start growing your design. But people that work in larger applications, for example, imagine that you have a feature like make a payment. You added some items to the shopping basket, and then, so your user story is like you need to make a payment, and then acceptance criteria, you need to validate the user, you need to notify the stock to see if the things are in stock, you need to call an external system that is a payment system, you need to notify the delivery system, and then send an email confirmation. So there are loads of stuff just to respond one single click on your page. Clearly, we won't have the entire system within this class. So using this approach, test by test, expecting this to emerge is very wasteful, because we know that we won't put 1,000 lines in here, right? So I don't think that this is a good approach for this type of tests. So that's why all these things, they have a big impact on your design. If you are always doing this way, it's also parallelizing this is quite hard as well. So, as I said, people work in different ways. That's like a general thing. Let's go to the outside in. There's a different style. Outside in is different. So imagine that you have the input of your application. That can be anything. An HTTP call, can be mobile, whatever it is, right? Another system, a queue, whatever the input is. So there will be a class here that will respond to this input. So the outside in prescribed direction. So normally what you do is you start testing from this one. So this class, imagine the make a payment scenario. There will be loads of other things that this class needs to do as soon as it says pay. So in the outside in approach, design happens in the red. Do I have a different color? I don't think so. So design happens in the red, because when you are writing your tests, you already know that's not going to be on the same class. So you say, I will call this class, but I need to make sure that it will call something in here that will validate my user. I don't know exactly what it is, but I need to call that. And then I will call something in here that will make a payment. So your tests in here, you say, I don't want this class to do anything, but I want it to coordinate the flow. So your tests now are all about going to your acceptance criteria, your business rules, identifying the different behaviors. If you can list all the behaviors for a single action, you can start specifying which collaborators or where you're going to delegate the responsibility. Your tests now are state-based. They test this collaboration between classes. This is a mock. So this is a concrete class. This is a controller or something. And then you will mock, you fake, you pretend that you have these classes and test the collaboration. So that's where you would start. And then what you do, once this is tested, you move on. You take the fakes that you have, or I won't go into the test double thing. There are many different types. I'll call them mocks to make it easier. So then you start testing this layer, test 3. And then you start implementing the concrete classes. And then this class may have multiple responsibilities. You may create different collaborators and mocks until you get to the output of your system. Output. That may be a database, a queue, or whatever, or just return something. So this is the outside-in approach. The interesting thing about this one is this is the execution flow. You also have the test direction that is aligned to the execution flow, and also the design direction. The interesting thing about this one is that every single class in here now is designed to serve. So you create a class in here to respond, or a method or whatever. So all the collaborators, they are clearly designed to serve this one, to help this one. And then this one is designed to serve this one. So this has an impact on your design as well. So this is the outside in. I think that I covered all this. Yeah. So this promotes a much better encapsulation as well, because you don't need to test state. So it tests behavior. So as soon as you start testing this way, you need to find a side effect that can be a collaboration or an output in there. So let's go for the problems with this one. So both have pros and cons. This style is way harder for novices and even for experienced developers, because you have no help for designing at all. You are completely on your own. Although you are using a TDD style, TDD is not driving your design, because you do design in the red. In the red, you specify how things are going to connect. What is the side effect? So there's no code in there. So in the refactoring, there is a refactoring as well. So in the refactoring, for the outside in, what we do here is a design refinement. So you make design decisions in here, you iterate, you make it work, and then in the refactoring, you say like, okay, is this still good? So, but it's basically you refine. Your design decisions start here, the classes start here. because you don't have any feedback, you need to have a far better design skill to use this. You need to understand where the responsibilities go, visualize how these connections are going to work. With not so good design skill, this is extremely painful TDD. It's not as easy as just call a method, query some state, and assert on it. So it can definitely lead to over-engineering as well, because you may infer that you need all these things. You don't have concrete evidence that you need. It's not suitable for exploratory code. So if you are doing some data transformation or an algorithm, is kind of you don't have a domain, nothing to anchor your nouns and verbs, your ideas. So you don't know what the solution is going to look like. This is not a good style. The classicist approach is far better, right? Because there's nothing to mock. You don't know what it looks like. So those are the two main design styles. Oh, TDD styles, sorry. I still think that none of them are efficient if you don't have good design skills. This one you are on your own. The other one, you need to have a keen eye to see what is in there, to be able to read what is in there and extract these things. Because 3D is just giving this very nice workflow. So I'll tell you a story to try to exemplify what I'm trying to say. I was having a chat with my wife and a Brazilian friend of ours. So we are all Brazilians, roughly same age, came to London or to the UK roughly the same time, so just over 10 years ago. So we were talking about when we were teenagers and the type of music that we listened to. So my friend and my wife, they asked me like the type of music that I used to listen. And I named a few bands, and both of them looked at me and said, ugh, how could you listen to that crap? I felt offended, of course, right? So how can they say that to me? And then the natural question is what you listen to. And then my friend mentioned a few bands, and then both my wife and I was like, how could you listen to that crap? And then, so okay, well, what about you? And then she said something, and both of us, right? So 3 people, same nationality, roughly same age, with a completely different taste in music. So then we started debating, what is good music? So that was an interesting conversation because for me, it was about the lyrics. So if the lyrics were good, the message was good, for me that was good music. My wife, she couldn't care less about the lyrics. She likes to dance. So if the music makes her happy, that's good music for her. My friend is a musician. He couldn't care less about lyrics or the rhythm. What he cares about is how the musicians play the instruments, the techniques that they use. So the way that the 3 of us see good music is completely different. So what we can get from this story is that if we don't know what good design is, we cannot test drive that. We cannot get good design, using tests or not, if we don't define what good design means. So I don't know if some of you, and I did that, would go to, when you are helping people or pairing with them or training them, you go there with that air of superiority, right? And so and then the developers is struggling to do the test and you go there, listen to your test, son, right? I've done that and I'm sorry for that, because that's a very stupid advice. So you cannot tell someone just listen to your test and expect that that person will internalize decades of design knowledge and, oh yeah, that's what I need to do, because that's not going to happen, right? So it's just like it's an ego thing. People feel important. No, just listen to your test as if you were a bloody guru, right, on the thing. So, but a lot of people say, no, but that's not that fair, because TDD definitely helps with good design. What I would say is that TDD constrain bad design, but doesn't necessarily lead to good one. So how do I think about this? Imagine that you have like feature complexity. So features have a very different degrees of complexity in our system. So systems have a mix of very complex features and simple features. So let's say So let's say that we have simple features, and you have very complex features. So when your features are around here, they are quite simple. A lot of people would say to you, for example, one of the arguments that TDD leads to good design is it will become so difficult to test that the test will force you to come up with a better design. It depends. It depends on the complexity of your features. If your features are on this area here, on the simple side, your tests are not going to harm you enough for you to rethink that you need to change your design. However, if your features will be along the very complex one, it will be very difficult to test them. But TDD will tell you, like, it's been extremely painful now. Sort that out. How? God knows. Right? So I'll give you a very interesting example. Imagine that you need to come up with a piece of code that will receive a list of integers, and you need to sort them. So you pass a list of integers, get them sorted. You can test drive this code, and you end up with a bubble sort. Right? So it's nice and clean, 5 lines of code probably. So it's a type of feature that your tests are not going to harm you. And you end up with a bubble sort. And you look at it, and say, well, it's actually good. It does the job. It's small. Understand? But if you don't know that there is a merge sort, quick sort, and many different types of sorts that are more performatic, you never get to them. There's no way that you can go from this to a better sorting algorithm. There's no way that you can test drive that, because like you have inputs and you have outputs. And your tests are saying that whatever you pass in, you get the right response. How do you lead that to a better design? You can't. And this is not only for algorithms. This is exactly the same thing for business code. If your features are here, you will test drive stuff. It will work. You look at it like it looks okay, and you will move on. So that's why this is one of the things that actually made me change my perspective that TDD leads to good design. It constrained bad one for sure. I have absolutely no doubt. But it doesn't lead to better ones. So just to recap, these different styles, they have an effect on your design, but that doesn't mean positive or negative. So on the outside in, you decide the order, and you have a way to start where the classicist not really, but all these decisions, you are making them. So all the design thing, TDD is this workflow, is this annoying thing that you have in there. It's like, are you sure about it? Are you sure about it? It's getting hard. Are you sure about it? That's what TDD does for you, but not much more. So, yeah, things like, for example, immutability is a good design principle, having things immutable. How do you test for that? How do you test for that? How do you say, no, this is mutable, it works. This is immutable, it works. How do you test for that? You need to understand these principles, right? There are more, but I'll move forward. So there are a few other things that are interesting as well. Let's talk about architecture. Macro design and micro design. So let's imagine that this box here is your application. So your application lives in an ecosystem. So there are other applications in there. This is meant to be a server or a computer, by the way. So yeah. So you have queues, we have like mobile. So it lives on you have many of these things in here, right? And databases, but there's a whole ecosystem of things, right? So it connects to different applications, to queues and stuff. This is, for me, this outer part, defining these technologies, how the system connects, where they live, all the things that are very hard to change, this is, for me, architecture. There's no clear definition, by the way. I'm just going to give one so it makes sense, so you understand the boundaries that I'm talking about. It doesn't matter if we agree or disagree on the boundaries, just to exemplify the boundaries. So this is architecture for me. Then there is your box, that's your app. If you slice that into different services, if you use an MVC framework, a delivery mechanism in here, if you put a hexagonal architecture, or layers. So the way that you split your packages and namespaces, all these things for me are macro design. It's still within, but you have control. And then whatever you do with your classes in here, this is for me is micro design. TDD shines in here, helps a lot with this. It gets less efficient as you move out, as you go to macro design and architecture. The problem is, a lot of people say, no, you can grow a system test by test. Unless you maybe can if you're doing something at home with a friend, a small mobile app, but that's not how slightly bigger organizations will do. So you will need to define these things up front. Even the way that you split your package, mainly in the macro design, is also a way to allow teams to collaborate. You cannot test drive that. This doesn't emerge. This type of design doesn't emerge from tests unless that you are working on your own. So there is a limit to what you can get with TDD as well. It's great in here on the detail, but these things in here, on the macro design, they have a far bigger impact on your software than the micro design. Of course, the macro design is painful as well if you get that, if there's loads of problems in here. But the way that you divide your application, how people collaborate within the same application, is what normally makes things very confusing. So, and then we got to all the non-functionals and functional requirements, or non-functional requirements, all this kind of stuff, and services, how you split, like, for example, splitting services. Microservices now is all the shiny thing. Everyone's talking about microservices. The interesting thing about when you talk about microservices, like people talk about technology, right? How you deploy them, how you monitor them, how you can replace them with different technology. We put in the cloud and you scale and blah, that's awesome. How do you decide the behavior of each service? Because we were pretty bad at it. Even when you have a monolith, just deciding where the behavior goes with classes that are in the same system, we kind of suck at it, right? And now we are doing a distributed ball of mud. That's what we're doing, right? So these things, you cannot test drive that. You need to look at your domain, speak to your business people, understand domain-driven design, bounded contexts, to decide how we're going to slice our service, the type of responsibility, right? The level of abstraction that each service is going to have. This is macro design. You cannot test drive that. Right? So now, I still had a question myself is, given a feature or given a piece of work, each one of us will start from somewhere. Right? So we have a user story. I give the same user story to many of you. And if I look at from where you started and what you've done with it, it will be very different. You may all satisfy the requirements somehow, but you made a decision of where to start, how much code you would write, how simple you would make, how more complicated or future-proof you're going to make it. We sometimes, I was trying to reason about it because people were like, how can you test drive code? Where do you start? How do you do that? They wanted to sit down and it's like, right, that's the kata, that's the code. I want to see how you do things. How do you grow that? I never thought about that. And that's probably how different people are not more or less successful, because I'm not sure if it's related to how easy it gets, but like internally, we decide a place to start. And that was kind of, I was thinking about it, it's like, subconsciously, how do I do that? So this was consuming because I wanted to get to these things. So not having a continuous whiteboard is quite odd. So let's get, okay, so for a given feature, you may know what is the most straightforward solution to the feature. So this would be, like, given a problem, this would be the most straightforward solution to it. Here is everything that is future-proof. Future-proof. And there are infinite types of things that you can do. So when we decide to start somewhere, and this is what this represents is trade-offs. So at some point for a given feature, we'd start from somewhere. Some developers start with the most straightforward. Some of them, they over-engineer everything. That's roughly how it goes. So this is straightforward, this is over-engineering. So what does it mean? They try to prepare their code for all the imaginable changes that they may have in the next millennium, right? So they put abstractions everywhere and stuff. The interesting thing about this is we all do that. The only thing that we do differently is to decide where to start. Some of us, we would start from here. Some of us may start from here. What is this? I call it the inflection point. Inflection point. So that's also inflection point. What does it mean, this inflection point? So inflection point, the way that I define this is how much investment are we prepared to make right now, taking into consideration what may happen in the future. So what is these things? So for example, these future-proof things, let's give some names. So it can be non-functional requirements. Could be, for example, security. Could be performance. But it could also be functional requirements. It could be, like for example, if we are doing a payment system, let's say that we are currently working on the Visa payment, and the next one will be American Express, right? So that could be, for example, support multiple types of trades, products, whatever your domain is, right? Let's put trades. So these can be anything. In the future, so we are here today, this iteration. In the future, we know that we may need to worry about security, performance, we need to support multiple credit cards, we need to support multiple types of trades, whatever your business requirements will be. So when we decide to start from somewhere, all of us, subconsciously, sometimes consciously, many times subconsciously, we start coding from somewhere. And normally, we have this in mind. There is a reason that we didn't start with the simplest thing, because we're trying to optimize for something. So there is a cost for over-engineering, no doubt about it. I think that everyone understands. But there's also a cost for under-engineering. Going for the simplest thing that could possibly work all the time, there's also a cost. Because every single new feature that you add, you need to change your system and refactoring. Sometimes go for 2 months of refactoring to add new features. There is a cost in that as well. The point is, how much do you know about? And that's why many of us, we tend not to be here. Because as developers, as experienced developers, we know the amount of work that we may have if we want to scale this application. So for example, deciding that you're going to start with multiple services that are separately deployed. Why did we start with 2 services, or microservices now so popular? Why didn't we start with a single code base in here? Because they are already thinking about something else. This is dangerous, because we can go back to the dark ages of the big design up front. But the problem that I see today is that we went from the big design up front, mainly in the 90s when I started, to no design at all, because we are agile. And we forgot that there are decades of design principles out there, right? So, but there is a reason to think about that. So I'll give you a better definition I need to read because I never remember what I wrote. So what is this? The inflection point defines the maximum amount of investment we are comfortable to make in a desired type of flexibility at a given point in time. Beyond this point, this investment is not worth anymore, right? So that's how we think. So we do that subconsciously, but how do we find the optimal one? So there are 2 ways that you can get to this. You can get from right to left or left to right. So left to right would be something like that. We know that for us to go live, we can have many releases to the UAT, have continuous deployment and stuff, but for us to go live, we need security or performance. It's a given. So we can start from one of these things, but then instead of, like we are in the early days of the project, instead of us start over-engineer everything or try to solve that right now, can we start pushing that to a simpler approach for now without losing this from sight? But then as soon as you may move to a point where simplifying further may make achieving this very complicated. So for example, starting with, you may not, an example, you may not want to start with 2 separate services and microservices, the whole infrastructure around them, but you could maybe start with submodules. Structure your packages in a different way. Or maybe just have 2 projects, but they are not separate deployable. They are assembled together. So this is the inflection point that I was talking about. This can be applied at any level. At the service level, at class level, and put how many types I'm going to put or how I'm going to split my class and stuff. So this is the same everywhere. And then there is the left to right. So we want to start with the simplest thing that will possibly work. But then how much do we know about our system? Sometimes you are working for a company that you are in a startup and everything is, well, we have no idea what we're doing. We are exploring stuff, right? We are purely in exploration mode. Even if you are working for a large organization, but you are working that area of your system where it's purely exploratory. In this case, the less that you know, the more uncertainty you have, closer to the straightforward you should be. However, not all applications are like that. You are not always in exploration mode. You can argue that, but for example, if you are in a much larger organization, they realized, and that was a real thing that happened to me, they realized that they had like 27 systems that did roughly the same thing, right? And then they said, well, we need to optimize that. The domain was extremely well known, extremely self-contained. So we just needed to optimize that. We had to write a lot of code and optimize the whole thing. But we knew the domain and stuff. We are not really exploring. We were exploring some technologies here and there. But so in this case, we actually could push a little bit here. We could start our code preparing for certain things. It was an internal budget, a long project, so we didn't need to keep going through refactoring, growing that. We could start with a slightly bigger team and work on different areas and stuff. All of these is pure software design. Pure software design is defining this. Because it's not only understanding where you are, where you want to go, but how much investment you make. And understand this, and preparing, start coding from this part, you need to understand, you need to design your system. right? There is another one that a friend of mine mentioned to me when we were talking about that. So you can define these inflection points. So sometimes they are here, sometimes they are here. And there is another thing that a friend said, like, we could also factor in what is the cost of moving back to straightforward if that thing that we thought that would happen actually didn't happen. So what would be the cost to simplify the code? That's an interesting thing because, as I said, this is a certainty thing, right? So this is, you are completely uncertain, do the simplest thing. You are fairly certain you are here. So for example, you have like 99% sure that the next feature, the next iteration, we have 1 week iteration, we are halfway through, and we know, and we are working on the visa implementation. As soon as you start the next iteration is the max implementation. I can move these a little bit. I can already prepare as I'm working, put the right interfaces, and I could do later on. This was just an example. But certain things you know that they are coming. So are you 100% certain, 50% certain, 20% certain? Where are you? And then understanding that, you end up pushing towards this side. So how this can be actually used? Because this was an interesting thing, because once you understand how we think, right, that's why we start from here. Automatically, I calculated this thing somehow. I may not even be able to reason about it and explain to you, but I said, I'm going to start from here, right? When we can understand this, imagine like in situations, I don't know if you had like technical meetings with very opinionated developers, and then we have like a piece of work to do in the next couple of months, and then 2 developers say, oh, we couldn't do this, and the other one says, oh, we should do that. Completely different ideas, not different ideas, but very different level. One is here, the other one is here. And then they start fighting, right? Because my idea, your idea, because your idea sucks, and all this kind of stuff, it becomes personal. And then the rest of the people are just like waiting for them to get somewhere, and they clearly won't get anywhere. So one thing that you can do, you don't need to have this graph at all. You just need to understand this. So if everyone understands what you can do. So you have 2 developers, and then you say, okay, what is your idea? And then she will describe that, and you say, okay, this is idea A. What is your idea? That's idea B. You put that on the board. As soon as you put that on the board, it's not personal anymore. So now the entire team is looking at 2 different ideas. And then, don't treat them as final, because those developers just came up with that stuff. Of course, it cannot be a final thing. But what you can do, have as a team, say, let's take this thing. Let's say that this is A. It's a very straightforward solution for the problem. Let's say that this is B. It's a far more complicated solution to the problem. So instead of discussing the merits of it and the technology and stuff, the conversation that you can have around this is like, what are you trying to optimize for? What is your fear? Why are you pushing that? And this person will say, no, because of the performance, because of the next functional or non-functional requirements and stuff. So this person has a fear. Somehow it's pushing, he's worried about something. This person here, he said, I think it is far simpler than that. Maybe they don't even have the full understanding. But now you start having a different debate, because it's not like person A against person B. It's more about we have 2 solutions. And understanding what people want to do with them and how far they want, we can agree on an inflection point. It's like, I think that this is good, we need to do that, but it's too early. I think we could still keep that a little bit simpler. And we still have that in mind, but I think that we should push it here. And what when they don't agree at all? So if you have developers, and even when you do that, they just cannot agree what the priority is or where the inflection point should be. What it means is that no one in the team has a clue yet. They don't know. They are always speculating what they need because they can't even agree where they should start or what they should do. And in cases like that, you need to be here. So you forget about everything, start with a simple approach, go through your project, iteration after iteration, and then you may have these discussions again. So once again, the more certainty you stay here, the more uncertain you are here, the more certain you go there. So I'm running out of time. So I have loads of examples of how this can be used, like in terms of architectural level and method level, right? So you can discuss these in many different ways. Another thing that is interesting is sometimes we enter these debates of my idea against his idea. We agree where we need to go at some point. So we say, no, this is definitely a concern, we need to address it, but I don't want to do that now. No, I want to do that now. Sometimes we start doing this, have this discussion. We agree the direction, and then we don't ask ourselves, what is the investment? Sometimes, going this extra leap, we may be talking about hours. In a full 2-week iteration, is this a big price to pay? Maybe we're talking about 2 weeks worth of work. In a 2-year project, in a large organization, it's not a big price to pay. However, maybe we're talking about 3 days. In a 5-week iteration, that's a lot to pay. So even understanding, if you agree where we want to go, understanding how much we want to invest is important, because sometimes this discussion is going to go away. We just say, oh, you know what, I agree with you, but I thought it was far more complicated. No, I'm just talking about 2 hours. Okay, let's do that. So that's how you can use that. So I think that, like, to conclude this is, so TDD is an awesome practice. My biggest fear when I put this talk together was that people would misunderstand me. I'm a strong TDD practitioner. I don't write code without test drive. I don't have any issues whatsoever test driving code and flipping from both approaches. I don't test drive UI. I'm kind of not very good at it. But TDD doesn't slow me down, let's put it this way. What I was talking about is, here, TDD has loads of advantages, and I absolutely love it. The whole thing was where the design comes from. And at least for me, and for people that I work with, they don't necessarily, it gives this nice workflow. This gives me this nice workflow, but the design comes from things that we already know and studied, like the example of the algorithms, the bubble, merge, and so you know this. Where do you go? There are solid principles. There are 4 rules of simple design. There are domain-driven design. It's a huge discipline. There's loads of stuff in there. Right? Design by contract, invariance, coupling, cohesion, law of Demeter, feature envy. So all these things, they exist. There are decades, patterns. There are loads of them. Not only the Gang of 4. There are many other ones at many different levels as well. So all these things exist. We shouldn't throw that away. Right? So another thing, different TDD styles. So if TDD is still hard for you, start studying design. It will make your life far easier, right? Also, use the right TDD style for the right problem. You can solve everything, use both styles. It's just like they will be harder or easier, depending on what you do. What I do, and that's not, I know that some of people here that I know very well, they don't agree with me. It doesn't matter. But like, I normally I don't even think which style I use. So I need to do something, I will write certain types of tests. But I don't, in my head, like, oh, this is class, this is outside in. I don't think that. But normally if I'm doing algorithm, data transformation, or if anything exploring, anything that I can't anchor my thoughts into nouns and verbs and domain, I normally do classicist and I explore. I let the thing grow, and my tests have a much bigger unit under test until I figure out what I'm doing, and then I'll split the things. If I'm working on business domain, that is more what I do. I normally do outside in. So choosing the right type of test is important. When you have these debates of TDD is this, TDD is that, or design, blah, blah, a lot of speakers or trainers and stuff, they don't give enough background because they may not even have the time. But sometimes you have a very simplistic view of the world. Projects are not the same. There are many different types of projects, and even within a project you may have very complicated things, very simple things that you need to explore, things you know exactly how they're going to look like, because you've done that a billion times. So areas of your system you need a lot of performance, areas that you don't care at all. So things are not that simple, right, that you say, oh, this applies, this doesn't apply. So I think that, although I love TDD, I really think that just focusing on simple rules of 4 rules of simple design and solid is a very, very simplistic view of the world. I definitely need far more than that. And just to finalize, it's just a clarification. We talk about these practices, TDD and simple design, continuous integration, and all this kind of good stuff, as if this was craftsmanship. It's not. We cannot just take something that already exists and call it craftsmanship. So craftsmanship is an ideology, right? It's a way that you live your career trying to find better ways of doing things. XP is a methodology, very well defined, with lots of very good practices, but these things are not connected. So in the craftsmanship world, we are always trying to find ways to do things better. And when it comes to code and design and stuff, the XP practices are the practices that we advocate today, because they are the best ones that we find today. But keeping them separately is important. Why is it important? Because it allows us to keep focusing on doing things better, but not being attached to a set of practices. So we are constantly questioning TDD, pair programming, all these things, because they are things that help us to be better, to do our job better, but they are not the only ones. And we should never stop trying to find better ones to replace. And this is craftsmanship, is this constantly searching for better ways, excellence, and this sort of stuff. So I think that that's what I had to say. Thank you.